Hi, this video is on the branch and bound algorithm for the 01 knapsack. This is embedded exercise 42 on page 76, and this is also what you're going to, if you choose to do project 6, you'll be implementing this similar algorithm, but of course without the picture. So the problem we have is W equals 16, and the items, item I has profits of I, weights of I, and for this algorithm it's convenient to do this. So we do 1, 2. So this is going to be a very small example, and in the routine exercise you'll be asked to do a larger one to get you ready for the same sort of thing on the test 3, and to help you be ready to do project 6 if you choose to. But it's a little bit laborious. So the items have first item is $40, weighs 2 pounds. I don't know what the units really are. They could be anything. 30 pounds, 5 and 6. 50, 10, 5, and 10, 5, 2. And of course, this third column is easily derived from the first two. It's just division, but it's convenient to have those out there because these are going to be used. These will be used to give us the bound. And this program and the traveling salesperson problem will be our examples where the bound is kind of slightly clever and meaningful. When we did the traveling salesperson problem on embedded exercise 41 using branch and bound, the bound was kind of stupid. It was just the tour side, the current weight versus the compared to an optimal tour, or to the best tour we'd found so far. So we're going to use the same idea, but it'll be somewhat more clever and more effective here. So we start off by, just wanted to point those out to you. You can refer to them on page 76 if you need. So we'll move things up here. That's what I'll be doing. So here we go with the tree. So the node format is very precise. We list the items, the weight of the dollars value of those items, and the weight. So we just right, and then down here in the bottom spot we put the bound. And also, very importantly, in the upper, we'll just always draw a little attached label. These are sequential nodes so we're going to number the nodes, give them unique identifiers in the order they're created. This is the required format for if you look at the desired output for project 6. So at the beginning we have no root node, we have no items. So the total dollar value, profit, and weight are 0. And what's the bound? Now you may say, well, that's ridiculous. How could we possibly know the bound? But the bound is just allows you to cheat. And it's to use partial fractions of items. But we still, to be as accurate as possible, don't allow more than one of each item to be used. So if you look at item 1, so what's the most, looking at the chart, the most we could possibly achieve is to use, so we could use all of 1, all of item 1, all of 2, and 1 unit of 3. So because item 2 weighs 2 pounds, item 1 weighs, so item 1 is worth $40 and weighs 2 pounds. Item 2 weighs 5 pounds. Sorry, is worth $30. We'll pretend they're dollars. $30 and weighs 5 pounds. So we're up to 7 pounds, and it's not 1 unit of 3. It's so at this point we can use. We have 7 pounds so far, and the W is 16, so we can actually use 9 pounds. So we're going to have 9 pounds of that to equal 16, and the dollar value will be 9 units times the value of 5. So that's 45. So the bound actually here is, this is really hard to read, is 40 plus 30 plus 45, which is 115. So we can't possibly make more money than 115. That bound becomes more meaningful as we make decisions about whether or not to use nodes. So the branch and bound possibilities tree says we go to the left, which is in the format of project 6. Going to the left means we don't use item 1. And we also go to the right. So to keep things tidy, I'm going to erase all this that I just wrote. We'll be going through those sorts of calculations a lot more. It's just really a common sense thing, which is pretty irritating to program, actually. It makes problems, project 6, a little bit interesting. All right. So we put in both of these nodes. So the way project 6 is supposed to work, we put in both of them, and we'll number them left to right. So this is node 2 and node 3. So and at that point we're done with node 1 once we used it to generate its 2 children. So node 1, if we don't use 1, we still have nothing. We still have, oh, I should have put 0 here, not a dash. We have nothing, nothing. And item over here, we've used item 1. If we use item 1, we make a profit of 40, and it weighs 2 pounds. And now the interesting thing is the bounds. So, and they will be different because they're different assumptions. So what's the bound over here? So the bound is we've decided not to use item 1, and so we're on level 1. So this is level 1. And again, I'm thinking here of project 6 a little bit. On level 1, you've already decided whether or not to use 1, and from then on, you don't have a choice. So on each level, we only have choice over 1. So what do I mean by that? Well, I mean we've decided not to use level 1, so the best we can do is to use item 2, which is worth $30 and weighs 5 pounds, plus item 3, which is worth $50 and weighs 10 pounds. So at that point, we've used up 15 of our 16 pounds limit, and so we can use 1 pound. So we'll use a fraction of item 4. I don't know how to indicate that, just part of item 4, and how much of that? We're going to use 1 pound's worth. And so that's 1 unit, so dollar-wise, that just adds on 2. So the bound here is 82. Okay. And for this bound, we're using item 1 for 2 pounds. So we have 1 giving us $40 or 2 pounds. And then we're going to use we just move down in order. We can use item 2 for $30, and it weighs 5 pounds. And then item 3, we can use all of item 3. Item 3 is worth $50 and weighs 10. Oh no, we can't. I miscalculated. Weighs 10 pounds, so we can only use 9 pounds of that. So we don't have. So just like before, we get the bound of 115. So since this bound here was computed using the assumption that we were using item 1, if we actually are using item 1, of course the bound is the same. Okay, so now is the really exciting moment. Which node, which of these 2 nodes should we use next? So we're doing the best first. Algorithm. because the bounds give us a pretty good, some estimate of the best we could possibly do. They're actually upper bounds. So we can't make, from this node, we can't make more than $82. So there's, on this node, if we pursue it, there's at least a chance of making 115. We may not be able to, but we know over here we can't make more than 82. So it makes some kind of heuristic sense to proceed with this one. So node 3 is the one we pursue. So node 3 splits off to give us node 4. And let's see if I can move this all over. Yes. We may come back to node 2 later, and node 5. Okay, so node 4 is the assumption going left means we don't use 2. So there's no 2, and since we're on level 2, once we made that choice, we'll never be able to use 2. On this side, we do use 2, so we say we're using items 1 and 2 for a total of $70 and weighing 7 pounds. And over here, we've got, when you go to ones to the left, you always just inherit the information. But the bound is different because now the bound involves never using 2. So we have 40, so we're using item 1, which weighs 40 pounds, it's worth 40 and weighs 2. And then we can't use item 2, so we go on to item 3, which weighs 10 pounds, so we can use all of it. And it's worth $50. And we haven't used up our weight, so we've still got 4 more pounds. So we can use a lot of item. So we're going to go ahead and use part of item 4. Circling it's probably a mistake. I'll jiggle it around to indicate that it's only partly used. So how much can we use? Well, the weight's the way to go. So we can use 4 pounds of it. So it actually weighs 5 pounds, but the cheating bound allows us to use 4/5 of the item. But the point is, every one of those uses 2. So that 8 is the 4 pounds we're using times the $2 per pound available. So that bound is 98. Okay, and now we can go over here on this level. We're using 1 and 2, so we're up to 70 pounds. So we're using 1 and 2, there's a total of 7 pounds and $70. And then can we use item 3? We can use a lot of item 3. We can use 9 pounds of item 3, so that what we get here is 9 pounds, not the full 10, times its cost, which is 5. So that's 115 again. So probably, that's the same calculation we used to get the other bound. Okay, so which node do we pursue next, the most promising one? So it's 115, 98, or 82, so we obviously, I'm pushing this technology to the limits. So we obviously want to use the 115 guy. So we split it off, and we get nodes, I think we're up to node number 6. And we only actually in node 7. So hopefully in this example at some point we'll be able to prune some things. But that may not happen for a while. So this is no 3. So it's 1 and 2 and never 3. And so we just inherit these guys. And this is using 3. So this is 1, 2, and 3. So 1, 2, and 3 actually adds up to 17 pounds. So we don't care about these other things, and this is pruned. So the 1, 2, and 3 is not a possibility because it weighs too much already. So we just stop, not surprisingly. So but now if we go over to this node, what's its bound? So its bound is we use 1 and 2, make $70 at 7 pounds, and then 3, no 3, so we have to go on to part of 4. This 4 weighs 5 pounds. Oh, we can actually use all of 4. So all of 4 is $10 and weighs 5 pounds. So we're only using 12 pounds and we're making 80. So that's not too exciting. If that number were bigger, it would maybe prune some other nodes, any node. So this is an actual. So this is pruned, but in a positive way. So we don't usually draw the X, we just say ta-da. So we can make $80. So the bound, oops, yeah, we've actually hit the end of the road here. So we prune it in a sense. I mean, we don't go on and consider whether or not to use 4 because it would, oh wait, I'm sorry. Yeah, I'm being an idiot. The bound is 80, and what happens here, so ignore all that. I could go back and edit it, but that wouldn't be that honest, would it? This is like live TV. All right, sorry. So none of that was true. It's interesting that we've used all the possible items to make the $80 at this point. But technically the algorithm doesn't realize that yet. Okay, so this guy's pruned. This guy's at 80. His bound is 80. And then we have a bound of 98 and a bound of 82. So not surprisingly, we go over here and pursue this one. So we pursue this guy. So I'm going to go over quite a ways, so this one, and notice we jumped up a level there. So this one it's on level 3, so this would be the no 3 or the 3. So this, and we're on node 8, I guess. So node 8, the node numbers are just for referring to, and they're useful in the program, but they're not super important, really. Okay, so focus on these guys. So no 3, so we have 1, 40, and 2. And what's the bound? The bound would be use item 1 for $48 and 2 pounds, and then go on. We've already made the decision not to use 2 and not to use 3 because we're on level 4. So the only choice is to use 4, and we can actually use all of item 4, which is good for a whopping $10 and weighs 5 pounds. So the bound is 50, and what I was saying before is we just stop here. No, wait. Sorry, I keep screwing this up. So that's just the bound. I'm being too human and too smart and looking ahead. So, on the other side, we use 3, so that's 1 and 3. 1 and 3 add up to 90, and they weigh 12 pounds. So the bound here is, not sure where I can put it. Maybe I'll put it up here. So I'll just squeeze it in over here. So the bound is we use 1 and 3 for 90 pounds. $90 and 12 pounds, and then can we use item 4? No, but we can use a lot of item 4 for the bound. So we're going to add in part of 4, and that's going to be 4 pounds, and 4 times 2 is 8, so we have the bound of 98 again. Okay, and so I'm making this sound harder than it is. So we look at all the live nodes, which is the 80, the 98, the 50, and don't forget these guys, and the 82. So the 98 is the winner, so we pursue it next, and we make spit off of it nodes 10 and 11. Okay, so 10 uses 4, and this, no 4, so that's just 1 and 3, 90, 12, and we're sort of at the bottom now, so this is achievable. So this is something we can actually do, 90. So 1 and 3 is legal and uses 90, so this is the best so far. This is the best we've seen, and we can make 90 bucks. So what that means, just to look ahead a little, is that we'll never pursue this node with the 82, oops, what the heck, or this node with the 50, or this node with the 80. So basically we're done. And we haven't filled it. There's a lot of the tree we haven't filled in yet, which is the joy of branching down. Okay, and here this is use for, so this is 1, 3, and 4, which adds 1, 3, and 4 adds up to 90, or sorry, 12 plus the weight of 4, so it adds up to 17. So we're done. We know that 1 and 3 wins with $90 and a weight actually of only 12, but that doesn't matter. I mean, that can happen. So to review what we're doing here, once we found we could actually achieve 90, we go back and prune this guy that had 50, this guy that had 80, and this guy that had 82. So every node that was live actually has been pruned. So if you look at this, we computed, there's a lot of nodes, so an entire half of the tree has been saved here almost, and we've only got, and we haven't done all of the tree. We've done a lot of it over here, but there's a little bit of it we haven't done. So in general, if you imagine, so there's really just a few nodes. There's like 4 nodes, I guess more, like 6 nodes. So maybe half the nodes close to it haven't been needed to be computed. But this is the big saving over here. So the choice on this example to not use 1 was sort of a foolish one, leading to a bound of the best you could do is 82 once you've decided not to use 1. and that involved using item 2, 3, and 4, and could only get 82. Anyway, I guess that's all I have to say about this. So it may be when you do the routine exercise on this carefully in your groups, it may help you and you may enjoy doing project 6. Thanks.